Okay, so the question that I missed on our exam was the goal script question. So I'm going to run through this one as part of the test wrapper. So the first thing it gives you is some constants. So it gives you k, which equals 9 times 10 to the 9. Gives you e, 1.6 times 10 to the negative 19. And then it gives you 2 point charges. One of them has a charge of positive. I'll name it Q1, which is 4e, and Q2, which is negative 4e. Okay, and then it gives you a position vector. So for Q1, the position is negative 1 e to the negative 5, 0, 0. And for 2, it's 1. E negative 5, 0, 0. So they're both on the x-axis. Okay, so now the first thing it asks you to find is the net electric field from the point charges to the observation location. And the observation location equals 0, 0, 3, e to negative 3. Okay, so first thing for the coding is it is determining net electric field. And for this, first you need to find your R vector. I'll name it R1. Going from observation, or going from your point charge to the observation point, which is your observation.pos. Actually, no, it's already a vector, so you need POS. Observation minus Q1.pos gives you that R vector from your position of the first charge to the observation location, and then the electric field of that first charge is your K value times your Q1 charge and that's times the unit hat vector of the R vector between the charge and the observation location. R1, norm of R1, divided by the magnitude of that same vector, and then you're going to square it. Okay? And that gives you the electric field of the first charge on the observation location. So now for the second one, we need the same thing. We need to find the same position thing. Looks like a subscript. They're actually right next to each other. Okay, so the second vector will be observation location minus Q2.pos. And that'll give you that same vector, but instead of going from the first charge to the observation point, you're going from the second charge to the observation point. All right, and then the electric field of that second point is the same K, constant we're given, times, oh yeah, these multiplications actually are just stars. K times Q2 dot charge times the unit hat vector of R2 divided by the magnitude of R2 squared. Okay, and then your E net is just the superposition of those two electric fields. Okay, so then part 2 is finding the force on the electron at the observation location. And to do this, it's just the net of the electric field times the charge of the observation location, which we said it was an electron, so it'll be negative E. So F net equals negative E times E net. All right, and that gives you your net force. And then the last part is creating an arrow. All right, so the last part is to create an arrow to display the force. So your force arrow equals arrow position, which is at your observation location, and then your axis will be your F net. All right, and that's your answer.